Hello, this is Accelerated Geometry 11.6, volume of a sphere. There's one little skill we have to review a little bit here before we get into the main information, and that is how do you find a cube root of something? So a cube root means what number multiplied by itself 3 times gives me, in this case, 729. So I'm going to show you 2 methods to do this on your calculator. Method number 1. This is the cube root. There's an invisible 1 on the 729, so I put that over here. Okay, then I can rewrite this without that radical symbol as 729 to the 1/3 power. So this is the index number, and this is the power on your main number, so the power goes over the index number. So that's 729 to the 1/3 power. Once you know that, on your calculator you can type 729 raised to a power of, and then put in parentheses 1 divided by 3 and press enter. You should get 9, and that's correct because 9 times 9 times 9 is 729. Method number 2 is also on your calculator. In your calculator, there's a math key. When you press the math key and you go down to option number 4, it is the cube root symbol. So you press the cube root symbol, a parenthesis comes up, you put in 729, you can put another parenthesis if you want, you don't need it, and then press enter, and you'll get the same answer. So for today in class, if we were in school, I would have you do an investigation, which is pretty cool, to find out what the volume of a sphere formula is. However, we are not in school, so I'll have to explain this to you as best I can. So today you are going to do an investigation, and then you are going to do 2 examples. So I'll explain the investigation, I'll go through it with you, and then I'll go through the 2 examples with you. So this is the slide that is originally there. I just left it there that says, hey, this is what you should have done in class today. Okay, so this is the investigation on page 561 in the book. And what I was going to give you was a hemisphere, a half of a sphere, a hollow hemisphere. And I was going to give you a cylinder, an empty cylinder, and I was going to give you some water. Now, this hemisphere, if I put it to the side and, just put it to the side of the hemisphere, the distance across the hemisphere, the diameter of that great circle, is equal to the height of the hemisphere. So this hemisphere has a radius of r and a diameter of 2r, and the hemisphere has a height of 2r. So the first thing you would have to do is fill the hemisphere with water, and then pour the water into the cylinder. When you do that, it asks what fraction of the cylinder does the hemisphere appear to fill? And the answer will be 1/3. Then I say fill the hemisphere again and pour the contents into the cylinder. So now why do I do that? Because 2 hemispheres are actually a sphere. So if 1/3 of the cylinder is filled with a hemisphere, 2/3 of the cylinder will be filled with a full sphere. If the radius of the cylinder is r and its height is 2r, then what is the volume of the cylinder? So the volume of the cylinder is the area of the base times the height of the object. So the area of the base would be pi r squared, that circle, and the height, remember I told you, is 2r. So if I make that look nicer, I put the 2 to the front, I put the pi next, and r squared times r is r, or r to the 3rd. The volume of the sphere is a fraction of the cylinder's volume that was filled by the 2 hemispheres. So remember, the 2 hemispheres, 1 sphere, fill 2/3 of the cylinder's volume. So now the question is, what is the volume formula? So here is 2 pi r cubed. That is the volume of the cylinder, and 2/3 of it was filled by the sphere. So if I multiply 2/3 times 2/1, I get 4/3 pi r cubed. And that is the conjecture number 94. The volume of a sphere with radius r is given by the formula, the volume equals 4/3 pi r cubed. Now, there's a whole nother way to explain this to you. I chose this way because we do this, it's easy to do in class, and it's kind of powerful to see this done, and kids can really see it well. There's another way to do this that I found on the internet, and I have that posted as a link on my CMH. So it's called Geometry 11.6. I'm going to call this one, I guess, Geometry 11.6 Part 2, maybe. Anyway, or you can go to Teams, to Files, Videos for Chapter 11, and it's also there called Geometry 11.6. And you can see the other way that they show of how to get this formula that the volume is 4/3 pi r cubed. It's pretty cool. If you have a chance, look at that. So Teams, Files, Videos for Chapter 11, and then Geometry 11.6. It's pretty cool. Okay, so now we have, I think, 2 problems. Here's the first one. As an exercise in her art class, Mona has cast a plaster cube 12 centimeters on each side. Her assignment is to carve the largest possible sphere from the cube. What percentage of the plaster will be carved away? Kind of a daunting problem. So I say, well, let's start with the volume of the sphere that we just learned, 4/3 pi r cubed. Now, if I look across here, remember it says the cube is 12 centimeters on each side. So therefore, if that sphere just fits inside, its diameter is 12, so therefore its radius would be 6. So in the next step, I substituted a 6 for r. 6 times 6 times 6 is 216. And 4/3 times 216 is 288. So the volume of the sphere is 288 pi. And if I put that in my calculator, it's 905. So 905 cubic centimeters for the sphere. Then I said, okay, let's find the volume of the cube. So the volume of a cube, this is a prism. So it's area of the base times the height of the object. So the base is a cube. So all the sides are equal, 12 times 12, and the height is also 12. So base times height for the base, and then height of the object, 12 times 12 times 12, and that turns out to be 1,728 cubic centimeters. So they want to know what percentage of the plaster will be carved away. So if I take the volume of the cube and I subtract out the space that is contained there by the sphere, that'll be all the extra stuff that I have to carve away to keep that sphere inside. So I took those two numbers, 1,728 from the volume of the cube, and subtracted the volume of the sphere, 905, and got 823. So now I need a percentage. So the amount that's going to be carved away is 823 out of the total cube of 1728. And when I divide that, I get 0.48, or 48%. And this one, this is a hollow sphere. Find the volume of plastic to the nearest cubic inch needed for this hollow toy component. The outer hemisphere has a diameter of 5, so you can see that from here all the way over here is 5. And the inner hemisphere has a diameter of 4, from here to here. So that means the inner hemisphere has a radius of 2, and the outer hemisphere has a radius of 2.5. Okay, so I think if I take the volume of the plastic and think of it as the volume of the whole outer hemisphere filled and everything, but then I subtract out the inner hemisphere, that will leave me with that core that goes all the way around there. So the outer hemisphere is half of a sphere, half times 4/3 pi r cubed, and the inner hemisphere is half of a sphere, so 1/2, 4/3 pi r cubed. Remember, the outer radius is 2.5, inner radius is 2, so I just substituted that in, and then I did some multiplication here and some canceling. 2 goes into 2 once, 2 goes into 4 twice, so I'd have 2/3. Same thing over here, this would be 2/3. Okay, when I put this in the calculator, I get 33. Put that in, I get 17. And so therefore, the inner, or the outer core of this, after I scoop out the middle, that plastic that I would need to create this component is 16 cubic inches. I hope you understand how these problems are done, and I hope that you have a good time doing the problems. If you have difficulty, make sure you're contacting me. Bye.